Yeah, hello everybody. Macroeconomics. First of all, some advertisement. So next Tuesday we will have the talk of Christopher Zuber from the Council of Economic Advisors, and he will present the annual report. And especially I think it will be also interesting in the circumstances that you have to write a little term paper where you have to deal with some country and describing the general economic performance. Okay, but let's step back to the start of the theoretical part of this lecture, and we started with so-called Keynesian economics. And within this model, commodity market, we make some strong assumptions. And maybe the strongest one is that we assume that there are no price changes possible in our economy, and that in general we take the view from the demand side. So we assume that all consumption and investment plans will be fulfilled, and changes we see, so to speak, the adjustment just from the supply side. And this means that this has to be possible, especially when we think about of just increasing the production. So we have to assume that production capacities are not fully utilized. And yeah, the motivation for especially this assumption is, good morning, that we take, so to speak, also the view just in the short run, and that especially in the short run, we can say that especially in the short run, we see price frictions, wage rigidities within the labor market. And then we are in macroeconomics. Of course, we can say that labor is at least one of the are also, I think, the most important input in total production. And so we can motivate that, so to speak, in the most important input market within our economy, we see also in practice price rigidities, so wage rigidities within this market. And yes, and from a theoretical point of view, it is always quite good to take an extreme position, because if we take then not only that prices are inflexible, but prices are really constant from a theoretical point of view, although of course also wages change. Think right now in the situation of the automobile sector, especially VW, they are now talking, the supply side and the demand side, of how to adjust wages in the next years. Although we see that, of course, also wages are changing in the short run, we can say quite slowly. And from a theoretical point of view, we just say they are fixed, because then within our model we see directly how our model is then working. So this we took together, and then we say, well, let's start from the supply side, from the demand side, and then we go to the expenditure approach for GDP. And there we have learned total GDP is just given by consumption plus investment plus government expenditure. And in our view, we abandon from the trade balance because this would be in our case just a fixed number, and therefore we leave it out. And within this model also short run, first we start with the assumption that investment and government expenditure are given. What is the motivation behind this? Also, investment plans and government expenditure. Think of the discussion about the public budget. These discussions are then always for 1 year. Also, for investment, we think that investment plans are more or less medium term or long term decisions, and therefore in the short run we can motivate to set this also fixed or given as exogenous variables, and that only we are left with consumption, and for consumption we make the Keynesian consumption hypothesis that in general we assume that consumption depends positively on income. Also, we think that an additional income can only spend with 100%. Therefore, modeling this with just a linear line means that CY, marginal propensity to consume, has to be less than 1. This means if we have an additional of 1,000 euros, then we cannot spend more than additionally 1,000 euro. And the reason why we introduce also this autonomous consumption, there I explained, this is from the empirical fact that we see in general the richer an economy, the less is the part of total income which this society is spending for consumption. So, and then this we all take together, that total demand is autonomous consumption plus also exogenously given investment and government expenditure plus marginal propensity to consume times income. And this is then why the so-called endogenous variable, this variable can change within our model. This is then via the equilibrium decision determined within our model. Therefore, the name endogenous. So the left part here, y equals yd, this is coming from our assumption, given demand yd, y total production, total income is following our total demand. And this we then had a look on the graphical representation of this model. So if we take just this equation, this is still a linear line adding up the exogenous parts. This is the cut of the vertical axis down here, and cy is just the slope of our linear line, so lower than 0. So a little bit flatter total demand with respect to the linear line with slope 1 through the origin, and this linear line with slope 1 through the origin, this is just representing our equilibrium condition, because all points on this so-called 45-degree line due to slope 1 are possible equilibria. So this is our equilibrium condition, and this is total demand. Well, and then our overall equilibrium within our model is just the cut of these two lines. And in the end, then we also discussed the stability of our equilibrium, and there, due to our assumption that production is following the demand, we argued that if we are starting out of equilibrium in a situation where demand is higher than production, then we start to increase production due to this demand. Then we can move to the 45-degree line, but we see there is still a gap between demand and production. Also, this is per assumption to be closed, and therefore we get a force into the equilibrium, and the same when we have the situation that production is higher than the demand at this starting income y0 prime, and then we decrease production by increasing inventory, and this process then is also giving us a force to the left. Therefore, we can say this is a stable equilibrium. Well, and now we want to make economic policy within our model. And there we go back in history 15, 16 years ago. The starting point with the crash of Lehman in summer, autumn 2008. We discussed this in the topic of the yield curve. That there we, in summer 28, we were just in the situation that we had already a crisis within the banking sector. But the economists, they were discussing, well, we see there is a crisis in the banking sector, but for example, we have these very high oil prices, 150 US dollars per barrel. So from this was deduced that still we have a very high demand in the economy, and the discussion was there, well, banking crisis, okay, but no crisis in the real economy. And then, a very big surprise came the large drop in the real economy in autumn winter 2008 2009, and then it was discussed, whoa, what we should do. And as I told you, during this time I was part of the economic staff of the Council Economic Advisors, and of course the government came to us and asked what we should do, because this was, by the numbers we saw in the real economy, the drop down, the largest crisis since World War II. And yeah, then of course you think of what we can do, especially from the point of view of the government. Well, putting money into the economy by just giving, for example, everybody in the country some money. And the logic behind this is when we increase the income of the households, then remember your microeconomic course, increasing income. In general, we think that we have normal goods. So an increase of income means an increase of demand for normal goods. And then the logic is we are increasing demand. So within this model, it means we start to increase also production. And this, of course, in this argumentation, you could think of that you can stabilize by giving money into the system by the government, the economy. But of course, all this has to be financed, and therefore you think also, well, if I take now a demand push by giving money into the system, I have to finance it in the starting point with credits, and I have to repay this in the future. So what you then really think of is, if I give, for example, 5-10 billion euros to the households, then my hope is that by increasing via this argumentation total production, this increase of total production should be larger than the amount of money which I have given in. So if I give in 5 billion euros, it should be hopefully 6 or 7 billion euros the increase. So I am possible to repay it in the future. And this compared to the money market multiplier, remember this, 1 over the reserve ratio. This we also call a multiplier and then a fiscal multiplier. And hopefully this fiscal multiplier is larger than 1. Because then we are giving money into the system. I know I have to repay it in the future. But if the effect is larger than the amount of money which I give to the system, then there would, in this case, be no problem to repay this in the future. Well, and also we were asked, is this fiscal multiplier in Germany larger than 1? Is it really a good idea to increase government expenditure? And not only we were asked, is this multiplier larger than 1? Also, all the other scientific institutions were asked. Well, and I have to admit, maybe we were the only institution which really gave an answer to the government in 2008 in the winter time. Because we started to calculate, we had just an overall econometric model, and the calculation did a colleague and me, and then the president of the Council of Economic Advisors in this time, Bert Rürup, he was going to Berlin in December 2008, and then he presented that we had the assumption that we had an estimation of a multiplier of roughly 1.2, 1.3. This was our economic interpretation, our econometric analysis for Germany. And after that, we started to increase public expenditure in Germany. And maybe the most famous one was the so-called scrappage allowance in Germany. I don't know if you remember it, because it's 15 years ago, and most of you, maybe you were around 10 years or something like this. But I think your elder brother or sister or your parents. What was this? This was the right. If you take your old car, still driving, still working, so to speak, everything okay with this car, and you go and that, well, I give it away and I buy a new car, then you obtained 2,500 euros. And in total, this scrappage allowance then was an expenditure in 2009 of 5 billion euros. And well, there was also the argumentation, if everybody gets 2,500 euros for a new car, what will happen? Well, within the automobile sector, just the prices of the cars will increase due to the fact that also the suppliers know that everybody has additional 2,500 euros. Or the other argumentation was, well, buying a car, this is in most cases for a private household a large investment because you don't get in general a car for 2,500 euros. So you will buy a car for 20, 30,000 euros and then you obtain roughly 10% of your investment. And then was also the argumentation, well, if this is a large investment for a private household, then they calculate their total budget, and though they maybe will today buy a car, but they interchanging, so to speak, the price that they today buy a new car due to the scrappage allowance, and they interchange it, not buying a new TV, not buying a new refrigerator, not buying some other larger investments. So that in total, you maybe would have an increase of production in the automobile sector, but a drop in production of other longer term private investment goods. Well, but if we look then at the data, we see here at the incoming orders this dramatic downturn in 2008, and that fortunately the incoming orders came very, very fast back for Germany. So within 3 months, 6 months, we were already almost at the level before the crisis. So these two argumentations, we have just an increase of prices or we have just a change in the demand for goods and not an increase of total production. This we see didn't happen in the aftermath of the financial crisis, and also we see it here in the total production. This is the downturn, dramatic downturn by -5% in 2009, but in 2010, into 2011, we grew in Germany in GDP, in real GDP, by 3 and 4%. So also within a year, within 1.5 years, we even increased our production to a higher level. If you compare this was summer 2008, and in summer 2011, we were already larger than before the crisis. Well, so it worked. And this process, this we can explain in our small model of the commodity market we created here in Keynesian economics. And we will start to try to explain this graphically. So we take the scrappage allowance. What does it mean? We have total demand is C0 plus CYY plus I plus G. And what does this scrappage allowance now mean? Scrappage allowance means an increase of total expenditure. So plus delta G, of course, larger than 0. And if this is our starting point, this would be YD equals C0 plus CYY plus I plus G. What happens now if we add additional government expenditure of delta G within our diagram? Hopefully you can help me. Please just try to describe what happens to total demand then within our diagram. We are starting from this total demand, and now this number is increased by delta G. If you remember, this is just a linear line. Somebody has an idea? The line would move up, yeah. And if we would be a bit more precise, just a general moving up, or can you be more precisely? Because does something happens to marginal propensity to consume, CY? Is something happening to this number? Oops. Let's just wait a minute because my Zoom meeting crashed. So back again. The line would move up. Could you be more precise? Well, this number is not changing, though the slope is not changing. And this not only a move upward, but a parallel move upward because the slope is not changing. And the amount of the upward moving is just delta G because this part is, so to speak, the old vertical cut at the axis. C0 plus I plus G. This is delta G. So the total amount of the cut at the vertical axis is now C0 plus I plus G plus delta G. So this would be the shift upward. YD prime equals C0 plus CY Y plus I plus G plus delta G. Well, and now we can just take the argumentation which we made from the stability discussion of our overall equilibrium, because this is now our starting point. In this case, due to the increase of government expenditure, we have an increase of demand. So we have now this gap here. We start by assumption in our model with the increase of production. Still we see the gap and the force to the new overall equilibrium Y1. So, and then the so-called multiplier is this increase of income from Y0 to Y1, and we have the increase of delta G. And the relation of these two increases we call the government or fiscal multiplier. Fiscal multiplier. Well, and now the question is larger or smaller than 1. And hopefully this one is larger than 1, because then it would be a good decision in order to stabilize or to push economy to increase government expenditure. Well, and this we will just do by the example, and a quite realistic example by the numbers. We had an increase of 5 billion euros due to the scrappage allowance in 2009, and you know, in Germany savings rate is around 10, a little bit higher than 10%. So we could say, to keep it simple, we take just the marginal propensity to consume to be equal to 90%, so 0.9. So what do we have in our economy now? The people in Berlin in winter time, 2008, 2009, they have discussed what to do. Well, let's do this, and let's do it in a total amount of 5 billion euros. So what we then at first have, just of course, this additional 5 billion euros. Financed via credit, okay, but in 2009 we have an increase of total income of 5 billion euros, equaling this increase of government expenditure. So 5. What would be the next effect? Increase of income delta Y1 increases now due to the Keynesian consumption hypothesis, also consumption. Increases due to the Keynesian consumption hypothesis, also consumption. C delta C of CY1, and how much we are increasing consumption. We have assumed that the marginal propensity to consume is 0.9. So we take these 5 billion euros, 90% of it, and 90% of these 5 billion euros we directly put in consumption. We just start to go shopping with 90% of these 5 billion euros. 0.9 times 5 is 4.5. So this would be then 0.9 times 5 is 4.5. But consumption is a part of total demand. So additionally also total demand again increases by 4.5 billion. And total demand meets total production. Why? So we have an increase of total demand of 4.5. So also total production, total income is also additionally increasing by 4.5. This means we have, so to speak, a second effect. Delta Y2 is 4.5. What else? Again, income has increased by delta Y2 is 4.5. Oops. Again, this increases consumption by C of Y2. Delta C of Y2 is 0.9 times 4.5. This is 4.05. Increase of total demand, YD, meeting total income, Y, and in the end, we have further on an increase of total income, delta Y3 equals 4.05. Well, and of course, now, theoretically, we go on with this process on and on and on. Overall, increase of total income equals the sum. Sum delta 1, delta 2, and so on and so on. So let's write it down. So delta y is 5 plus 4.5 plus 4.05 and so on. Again, remember money market multiplier. This is the same process. We just write 5 times 0.9 to the power of 0 plus 5 times 0.9 to the power of 1 plus 5 times 0.9 squared and so on. So let's take out of the bracket the 5 0.9 plus 0.91 plus 0.92. What was it called? Such a series? This is really fundamental for growth processes, not only in macroeconomics. And in economics, we almost always look at profit growth, expenditure growth, cost growth. So how does we call such a series? This is again the geometric series, and for this geometric series we know that this is 1 over 1 minus 0.9. So 5 times equals 5 times 1 over 1 n is 5 times 10. So 50. And this is, of course, a really nice situation if we would find this in reality. So just giving into the system 5 billion euros, we end up with an increase of total income of 50 billion euros. So then delta y over delta g is 50 over 5 is just this 10. So this is our fiscal multiplier. And there you see now how this increase is feeding through our economy within this model. Well, of course, in reality, we won't find a multiplier of 10. As I said to you in when we did the calculation in winter 2008, we came roughly to a multiplier of 1.2, 1.3 for Germany. And of course, in reality, you have other frictions, and you have, of course, also price increases, price changes. And but if you are in a situation where this multiplier is larger than 1, then you can really think of just increasing government expenditure. But of course, also you have to keep in mind you cannot always do this, because then we are just moving from this Keynesian economics into a situation which is better described by a neoclassical view, and then you have more the effect of just price increases. But in the short run, it is, I think, in my view, always at least worth to ask yourself, are we just in a situation where we could shortly push or stabilize the economy? And right now, this is one of the central discussions in Germany, and this will be also one of the central discussions in the forehand of the next polls in February in Germany. Okay, so the multiplier is just the increase of one variable if another variable is increased by 1 unit. And then the definition of government expenditure multiplier, or I called it fiscal multiplier, is the change of equilibrium income by the increase of government expenditure by 1 unit. And this we also want to do just by a little example. Oops, what's this? There we are. And well, first of all, given consumption 100 plus 0.8 times y, investment 400, government expenditure 200. First one, calculate overall equilibrium. And we will also do the graphical representation. What do I have to calculate? These are my given numbers. So what is total demand? Test, test. Do you hear me? Yeah, please. About this I talked the last half hour. So total demand, expenditure approach of GDP, C plus I plus G. Then I just put in my numbers. 100 plus 0.8 y plus 400 plus 200. Summing all up my exogenous numbers here is 600, 700 plus 0.8 y. So this is the vertical part here, 700, slope 0.8, roughly this, yd equals 700 plus 0.8 y. 45-degree line through the origin, yd equals y, total equilibrium. And this number we want to know. So then equilibrium yd equals y, then 700 plus 0.8 times y equals y. This we have to solve for y. What do we have to do? Solving for y. Class 7 or 8 in school, equating to linear lines. So minus 0.8 y, 700 equals y minus 0.8 y. Taking out of the brackets y is y times 1 minus 0.8, dividing by 1 minus, 1 minus 0.8, and we end up with 700 over 1 minus 0.8 times is y star, 1 over 1 minus 1, 1 over 1 minus 0.8 is 1 over 0.2. This is just multiplying by 5. So y star equals 5 times 700, 3,500. Okay, change in equilibrium. If government expenditure is increased by 100. Oops, increased. So let's take red. What happens in our diagram? Delta G equals 100. Upward shift of our demand curve by 100. YD prime is just 800 plus 0.8 Y. Well, now we could start overall from this calculation, doing the same calculation, but we also know only this number changes. So we obtain is 5 times 800 is 4,000. Well, and then we can say delta y over delta g is very surprisingly 4,000 minus 3,500. So this is 3. This would be 2 over 100 is 500 over 100 is just 5. Where do we also find the 5? Just here. 1 over 1 minus 0.8 is 1 over 0.2 is 5. Or let's do this in green. We abandon from our example of these numbers. What is this 700, 800? This is just C0 plus I plus G. This 0.8 is just Cy. And this is always the same calculation. So in general, we have y star is C0 plus I plus G over 1 minus Cy. We are interested in delta y over delta G. What is this mathematically? The first derivative of equilibrium income with respect to our exogenous variable government expenditure. So this is, of course, if we only look at government expenditure, just a function of government expenditure. So this is y star of prime of G. What is the first derivative? This is our variable. These are all constants. So the first derivative is just 1 over 1 minus Cy. Of course, this should be the case that this is the fiscal multiplier. Since, of course, we have derived the same here. This is also just 1 over 1 minus marginal propensity to consume. So, okay, this we don't need because I have already put here the graphics. So let's delete this one. Yeah. And then let's look at the general interpretation of this starting point of our theoretical discussion. So in general, we can say since we have fixed prices due to the assumption of fixed prices. In general, disequilibria in the overall economy could be the case. So to speak, due to our exogenous variables, we obtain our income, Y star, and with respect to this total income, we have a corresponding unemployment. But this is, so to speak, set by the exogenous variables. So it could be then the case that we have a situation with high level unemployment. Or the case that the economy is overheating if somebody has the stupid idea not only to push once or twice the economy, but by permanently pushing the economy by just increasing government expenditure. Greece has done this after the introduction of the euro for almost 10 years. Afterwards, you had, I think, not directly, but indirectly, employment in the public sector in Greece of 50 to 60%. Well, that then, in the end, also without a worldwide economic crisis, your country has to crash sometime. This is more or less a must. Well, so in general, the interpretation, if the economy works like our description here, we could say we have permanently to steer our economy. We have always to increase, decrease government expenditure in order to obtain our aim. Think of the magic square, high level employment, to obtain a situation with low unemployment rates. While in the neoclassical view, you would just say, well, let's do it by the labor market. Let's do it by wage changes. Okay, so here the economists, if they are asked by the government, they would always say, well, you always have to do something. Okay, some time left. So, of course, this is a more or less total aggregated view on the economy. To move to more reality, we of course have to widen our model. And this model is then increased the, so to speak, ISLM model, because what we have now, oh, again, my spelling is not very good. Still, we have no adjustment of commodity prices. So we fixed price level at 1. And still, we say we have this demand side driven economy. But of course, and this was one large part in the descriptive part of the lecture, we have this very central good of money, which we are using for interchanging all our goods. And therefore, in order to be realistic to describe a modern economy, of course, we have to describe the money market. So the money market is right now not incorporated in our model. So this connection between nominal and real variables are missing. And this is then given by the so-called ISLM model. And this we want to start to discuss also today. The first one is we still take our model, which we have introduced, the Keynesian commodity market. And what happens there? We just have investment equals savings because our equilibrium condition was YD equals Y. This we can rewrite to YD minus consumption. What is this? This is just investment. Since YD was C plus I plus G, so, or general investment. Because also these two numbers together we could interpret as general investment. So, and then you take the circular flow. There we said in the financial institution sector, we have that we sum up all savings, and from these savings, we financing our total investment. So this equals then our total savings. So this equilibrium condition here translates just by subtracting consumption into the equilibrium condition investment equals savings. And therefore, from this, we deduce an equilibrium condition from the commodity market. This is called the IS curve because this is in relation to the equilibrium condition of investment equals savings. And now we take additionally the money market, and in the money market we also look at the equilibrium condition. And this is just money supply equals money demand. And especially money demand is just the demand for liquidity. Because remember when we discussed the different incentives to hold money, this was the the preferences for liquidity. Demand is just derived from the preferences for liquidity. Derived from preferences for liquidity. Well, and therefore we call this LM, liquidity meets money supply, and this is just also written as M. Money supply equals money demand, preferences LD for liquidity. This letter I already introduced when we have talked about money demand. And therefore, overall, this model is called ISLM. And this is more or less, so to speak, the central model which you can deduce from the general theory of John Maynard Keynes. There he has only written down without any mathematics, and later on an economist called Hicks in the 1940s, he formalized it in the way we are dealing with this model today. So then what do we need, especially if we look at the money market? Then, of course, we have to talk about interest rates. So what we are now additionally introducing is the variable of interest rates within our model. Then for the connection of both markets, we introduce interest rates. And where are feeding in interest rates in the commodity market? Well, of course, here just in the investments. And now, until now, we said investments are just a fixed number, I0. And now we introduce a part of investments depending on interest rates. Investments depending on interest rates. Well, and a very surprising assumption we make here that now investments are negatively dependent on interest rates. Because why? Interest rates are more or less just the price of credits. The higher the price of credits, the lower investments. So I of small I smaller than 0. Or, and hopefully you have heard already from this in your investment lecture or mathematical lecture. And this is, then this concept that if you have an investment project, then you have some idea. I have a starting point of the investment of A, and I think of that in the future I obtain in the first period a return of E1. So starting investment amount return in the first period. E2, return in the second period, and so on. And then you can calculate the so-called internal rate of return. This hopefully you have already heard. Then calculate the internal rate of return. And there you just said you think of how much should be my internal rate of return. That's my net present value equals just 0. So minus A plus E1 over internal rate of return first period, present value of the first return, plus E2 I star squared, present value of the return of the second period, and so on. And this has to be 0. This solve for I star. So then for every single investment project within our economy, I can calculate an internal rate of return. And then I ask myself, should I really invest in this project? Then again, opportunity costs. I comparing to an alternative. And what is the alternative? Then let's say this is investment project I1. Should I invest in I1? Well, the alternative is taking the money of amount A and buying government bonds. Go into the capital market. And at the capital market, I obtain the general interest rate within my economy. If my internal rate of return is larger than the alternative, so I interest rate at the capital market, then I invest in my project. Well, and from this, of course, also I can then argue the higher the alternative, the lower is the number of investment projects which are still taken in my economy. And total investment is the sum of all investment projects. So if I increase, then the market interest rate, the number will go down of my investment projects and total investment will decrease. Or what I already said, well, just this opportunity cost argument. So this is then the argumentation that we have a negative dependence of investment on interest rates. Well, and this now we take together. Again, this we already know, our commodity market. Still we have YD equals C0 plus I, and this is now depending on a specific interest rate. Let's say I1 plus G plus Cy times Y. So again, here we have C0 plus I, now depending on an interest rate, I1 plus G. YD equals Y. This now means that our equilibrium income is depending on a starting interest rate. And now what happens if we take an Y2 equaling C0 of I2 plus G plus Cy times Y with I2 larger than I1. What happens then in my diagram? Well, this number is now depending on a higher interest rate. Compared to this number, it has to be lower because of the negative dependence of investment on interest rates. This means I of I1 is larger than I of I2. Let's take this in red. So this number here decreases. The cut of the vertical axis now decreases. So here we have C0 plus I of 2 plus G. So qualitatively, we obtain the same when we have compared to the case when we have discussed the increase of government expenditure. But now not G is changing, but I is changing and I is decreasing. So we obtain a parallel downward shift of YD. This means our equilibrium income is decreasing. Y star of I2. And now we can go to a diagram with interest rates and income that, let's start with black, this number going vertically downward, Y star of Y1, and we are starting with a high interest rate. Sorry, with a low one. Oops. Since I1 should be lower than I2. Now we are increasing interest rates. Let's say I2 is somewhere here, and the corresponding income to the higher interest rate, let's do it in red, is the lower income. So we obtain then a pair of interest rate and income for I2 and a pair of interest rate and income for I1. And then hypothetically, we can do this thinking for all interest rates, for higher interest rates, lower interest rates, and so on. This we do for all interest rates I. And then, of course, qualitatively, we obtain all new pairs of income and interest rates. So we obtain just a function deduced from the commodity market for the dependence between interest rates and income. And since this is deduced from the commodity market equilibrium, y equals yd, or investment equals savings, this is called the IS curve. Well, and then next Thursday, we are talking about the money market. And there, remember, here, if you go back in the slides in the lecture, we have already deduced a money demand function depending on interest rates and income. This we set equal to money. Money then we assume is set by the central bank. And from this, then we also can deduce a dependence between interest rates and income from the money market. And this then we take together, and then we obtain the overall equilibrium in our economy. But about this, we will talk next week. Thank you very much.